Hello, this is Mr. Collier, and today we're learning about special triangles. Okay, so we have two types of special triangles we're going to learn about today. The first one we call the 45-45-90 triangle, because it's the right triangle you get when you have 45 degrees for one of the acute angles. So if you have a 45-degree angle, the other angle is going to be 45, so you have a 45, 45, 90 triangle. That's where the name comes from. And one of the reasons this triangle is so special is because it turns out this triangle is an isosceles triangle. Okay, so in this type of triangle, you have an isosceles triangle, so the two sides here are congruent. So if this side is 1, then this side is going to be 1. And then we're going to work out the other side length, the hypotenuse. Okay, so we have these two sides, or two legs, are going to be equal, and then we're going to figure out the hypotenuse here by using the Pythagorean theorem. So the hypotenuse is equal to 1 squared plus 1 squared, which is equal to 2. So the hypotenuse is equal to the square root of 2. Okay, so here we have this side length is root 2. So we have the sides 1, 1, and root 2 in that triangle. Now if we look at a slightly bigger 45, 45, 90 triangle, okay, let me just label that as 45, so that's 45, 45, 90. And you know if it's an isosceles right triangle, it's going to be 45, 45, 90 triangle anyway. So we're going to find this hypotenuse here. So in this one we have hypotenuse squared equals 2 squared plus 2 squared. So hypotenuse squared equals 4 plus 4. Hypotenuse squared equals 8. So hypotenuse equals root 8. And if we rewrite this slightly, we can see a pattern develop. So I can rewrite this as root 4 times root 2, which is 2 root 2. So the hypotenuse is 2 root 2. Okay, so perhaps you can start to see a pattern develop. I can do the same thing for this one. This is 3 and 3. I can also work this out to be 3 root 3. So what we get here is we get each time, oops, let me just back up a second. Made a slight error. Here we're going to get 3 root 2. So let me actually work that out. The hypotenuse squared is going to be equal to 3 squared plus 3 squared. Hypotenuse squared equals 9 plus 9. Hypotenuse squared equals 18. H equals root 18, which is root 9 times root 2, which is 3 root 2. So as you can see the pattern that's developed here, each time the hypotenuse is going to be root 2 times one of the shorter legs. Okay? So each time we, if you know this side is 3, you know the hypotenuse is going to be times root 2. So that's the pattern that develops. Okay, so we can see that for any 45, 45, 90 triangle, if you know the side lengths are a certain number x, then you just multiply by root 2 to get the hypotenuse. Okay? And if you know the hypotenuse and you want to get the length of one of the sides, then you have to divide by root 2. Okay? So if you go that way, you divide by root 2. If you go this way, you multiply by root 2, which we're going to see in a couple of examples a bit later. Let's take a look at another type of special triangle. The 30, 60, 90 triangle is also special. There's a special relationship there. So this is not an isosceles triangle, so they're not equal. You have a shorter leg and a longer leg, and of course the other side is called the hypotenuse. So they're different sizes, but there's a special relationship, as we're going to see in a second. So let's take a look at this 30, 60, 90 triangle. So we have 30 and 60 here. And to see the relationship, what we can do is we can draw in an exact copy of the other triangle, a congruent triangle here. That's also a 30, 60, 90 triangle. Okay, and what happens is we get a triangle that is 60, 60, 60, so that's an equilateral triangle. So if we say that this side here is of length 1, okay, then this also has to be 1, and because it's an equilateral triangle, this has to be 2. So you can see here we have 1 and 2, and now let's work out what this side is going to be. Okay, so that's 1 and that's 2, so the shorter leg is 1 and the hypotenuse is 2. We're going to work out the other side. So let's work that out now. We're going to have x squared plus 1 squared equals 2 squared by the Pythagorean theorem. Let me square these numbers and I get this. Subtract 1 from both sides. X squared equals 3. X equals root 3. So this quantity here is root 3. Okay, so we have this relationship here. We have 1 for the shorter leg, 2 for the hypotenuse, and the longer leg is root 3. So if we look at, say, a bigger 30, 60, 90 triangle, let's say this is 2. Okay, then this hypotenuse is going to be twice that length. And to get from the shorter leg to the longer leg, we can just multiply by root 3. So this is 2, so this is going to be 2 root 3. And this relationship always holds for any 30, 60, 90 triangle. Okay, so in general, if we have a 30, 60, 90 triangle, the shorter leg is x, the longer leg is x root 3, and the hypotenuse is twice the shorter leg. Okay, so that's our special relationship for a 30, 60, 90 triangle. Let's take a look at some examples to see how we can use that. So here we have a couple of examples where we're going to find the missing side lengths. In the first example, we've got a 45, 45, 90 triangle. So we know these sides are congruent. That's going to be 4. And remember, in a 45, 45, 90 triangle, the hypotenuse is root 2 times the legs. So that's going to be 4 root 2. Okay, so you always have that relationship in a 45, 45, 90 triangle. 1, 1, root 2 is the relationship, so I multiply by root 2. Okay, now here we have the hypotenuse. Okay, we have the hypotenuse, it's 12. And if you multiply by root 2 to get from one of the legs to the hypotenuse, then to go backwards, go from hypotenuse to the leg, you got to divide by root 2. So what am I going to do here? I'm going to find this side length by doing 12 divided by root 2, which is, so we can write 12 divided by root 2 here. Alright, and you can simplify that as well, or I'm just going to leave our answer like that for now. Next example, next couple of examples, we have some 30, 60, 90 triangles. Okay, so remember the relationship, you should always remember this, is going to be 1 for the shorter leg, 2 for the hypotenuse, root 3 for the longer leg. So we have the shorter leg here. So the hypotenuse is going to be twice as big, which is 6, and the longer leg is going to be root 3 times the shorter leg, so that's going to be 3 root 3 for that one. Okay, in our next example, we're given the longer leg. Okay, so if we multiply by root 3 to get from shorter leg to longer leg, then to go backwards, we're going to divide by root 3. So we're going to do 5 root 3 divided by root 3, and we get 5 for the shorter leg, and the hypotenuse is twice the shorter leg, so that's going to be 10. Okay, you can use Pythagorean theorem to verify results, and you'll see that this is accurate. Alright, one more example, or two more examples here. So here we have a 45, 45, 90 triangle. It actually doesn't say that. It should say that in the question. That's a 45, 45, 90 triangle. And we know that the ratio is 1, 1, root 2. Okay, so to go this way, we multiply by root 2. Now go from hypotenuse to leg, we're going to divide by root 2, which is what we're going to do right here. So to get this missing side length, we're going to take root 6 divided by root 2, which equals root 6 over 2, which equals root 3. So these side lengths are both root 3. And here we have should be labeled 60, 30, 60, 90 triangle. And we have the hypotenuse. So remember, it's always in this ratio. 1 for the short leg, 2 for the hypotenuse, root 3 for the longer leg. We have the hypotenuse, and we want to get to the short leg, we will have to divide by 2. So that's what we're going to do here. We're going to do 4 root 3 divided by 2, which equals 2 root 3. So we have 2 root 3 for our shorter leg. And now to get to the longer leg, we've got to multiply by root 3. So I'm going to do 2 root 3 times root 3. Root 3 times root 3 is going to give you 3. So that's going to be 2 times 3, which equals 6. Okay, so if you multiply 2 root 3 by root 3, we get 2 times 3, which is 6. So 6 is our longer leg length.